Sure. The last question which we did in last class. Just read the last question which we did in last class. Okay. So I defined in the last part about third application of dimensional analysis. Okay, I'm giving you one more problem related to that. Force, the viscous force experienced by a body going through fluid depends upon first coefficient of viscosity eta, radius of body r, and third velocity of body v. Put proportionality constant k to be 6 pi. Dimension formula of eta is ml minus 1 t minus 1. Dimension formula for radius is capital L, and for velocity is lt minus 1. Just put all these values and try to find formula for viscous force. I'm defining a relation initially. First of all, we have to define viscous force. So it will be F is equals to, there should be some proportionality constant K and having dependency over three different factors. So it will be eta raised to X, radius raised to Y, velocity raised to Z. So this is your first formula related to force depending upon radius, eta, and velocity. Is it clear? Share, any doubt? Now just write the dimension of left hand side and right hand side and compare the exponent of each part. You will get value of x, y, and z. Try to solve. Share, do you have doubt? Is it clear? Okay. Try to solve. In this expression, we have left hand side as 4, so it will be ml t raised to minus 2. In right hand side, we have k, which is a dimensionless quantity, so just neglect it. Dimension of eta is ml to the minus 1 t raised to minus 2. Minus 1 raised to x. R is length raised to y, and velocity is Lt minus 1 raised to z. Now on simplifying, you will get m raised to x, L raised to minus x from this, plus y from this, and plus z from this. Similarly, t raised to minus x from this part, and t raised to minus z from this part. Now just compare the exponent of each segment on left hand side and right hand side and try to define value of x, y, and z. So on comparing, exponent, x would be equals to 1, minus x plus y plus z is equals to 1, minus x minus z is equals to minus 2. So put the value of x in this part, you will get z. Put the value of x and z in this part, you will get y. Try to solve. put the value of x to be 1 in this part, it will be -1 minus z is equals to -2. This -1 on moving to the other side will become +1. -2 plus 1 will be -1. And on solving, you will get z is equals to. Now put the value of x and z in this second equation. It will be -1 plus y plus 1 is equals to 1. This one and this one would cancel out. So you will get y to be just +1. Is it clear to this part? Shab, any doubt? Okay. Now put these values of x, y, and z in this first expression and k to be 6 pi. So it will be f is equals to 6 pi eta raised to 1, r raised to 1, and velocity raised to 1. So it will be force is equals to 6 pi eta r into v as viscous force experienced by any object. Is it clear? You have written this? Sure. You have written this? Okay. Just right now. So this is how we define or formulate any formula depending upon their dependency. Now we have certain limitation of this dimension analysis. Limitation of dimensional analysis. First limitation is using dimensional analysis, you can't find the value of proportionality constant, that is k. So it is unable to define or calculate the value of proportionality constant. Next is, in all of the previous problem, I defined you the dependency of a given quantity on maximum of just 3 terms. Since this dimensional analysis is applicable to derive relationship up to maximum of just 3 terms, beyond which it will give you sometime correct result, sometime wrong result. So it will be applicable to derive a relation up to maximum of 3 terms only. Next is, we have certain relationship which contain plus or minus. Suppose S is equals to ut plus half at square, in which this term and this term are related by plus sign. Similarly, b square is equals to u square plus of 2as, in which this term and this term are related by plus sign. So these type of relation in which quantities are related by plus or minus sign are termed as composite relationship. it is unable to define the value of proportionality constant. Okay, why? So the relationship between quantities containing plus sign or minus sign is termed as composite relationship. So using dimension analysis, it will be not applicable to derive these type of relationship. Using dimension analysis, you will be able to calculate relationship containing product or division. So it is not applicable to derive composite relation, means containing plus or minus sign. It is applicable to derive the relation between quantity related by product or division. Is it clear to this part? Shab, any doubt to this? Written. Fire. Okay. Now the next part is to define theory of error, in which the first term we start with. What do you mean by accuracy and precision? Let's say if you have to calculate value of gravity, so it will be 9.8 meter per second squared. So if someone measures this particular gravity using simple pendulum or any other experimental, let the result comes out to be 7 meter per second square. For some other, it will be 9.8 meter per second square, 9.85 meter per second square, and so on. So just check which of these experimental value is more closer to this particular actual value. We take this particular actual value as true value, and these are some experimental result. Experimental value. So just compare which of these experimental value is more closer to this particular true value. Yes, Shah, tell me. Wahid, which of these experimental value is more closer to this particular term? In this first part, we have 9.76, second is 9.81, third is 9.85. So you'll say 9.8 is the most closest to this true value. So the numerical value or the experimental value which is most closest to this true value is termed as accuracy. So accuracy simply defines you the closeness of experimental value related to true value. Now, what do you mean by precision? Precision simply depends upon least count of a particular instrument. Least count is nothing but the smallest value which can be measured by an instrument is termed as least count. So you will say smallest value an instrument can measure is called least count. So smaller the value of least count, it will give you more precise result. So smaller the value of least count, it will be more precise data. Or you may define precision and accuracy on the basis of number of significant figure. First, the total number of significant figure in a data defines the accuracy. So the more the number of significant figure, it will have more accuracy. But for precision, the number of significant figures after decimal would define precision. So it will be the total number of significant figure after decimal in our data will define the precision. I'm giving you one example. Simply just remember what do you mean by significant figure. All non-zero digits are termed as significant figure. I'll define you some rule how to calculate it in later section. Suppose if you have 4.25 and if you have 4.256 or 252. So which of these two numbers containing larger number of digits? So you will say this has only two digits or two significant figures, and this have four significant figures. So you would say this is more accurate as compared to this digit. Similarly, if you want to calculate precision, let's say 2.42 and sum is 2.4. Here we have two significant figure after decimal. Here we have only one significant figure after decimal. So this number containing larger number of significant figure after decimal. So this will be more precise measurement as compared to this. Is it clear? So this will be more accurate and this will be more precise. Sure, any doubt till this? Just write it down. In precision, you may also remember it will define you the closeness of experimental data within themselves. So it defines closeness of experimental data within themselves. I'm defining you, giving one more example related to this. Shwab, you have written. Okay. You have to define about accuracy and precision, whether it have high accuracy or high precision, low accuracy, low precision. This central term is defining you the actual or the true value related to that measurement. So let's say in first part, we have this observation. In second part, we have this observation. In third part, we have this observation. And fourth part, we have this observation. Now suppose if I have to define for the first part, all experimental value are more closer to this true value. So you will say it having high accuracy. Next, since all of these experimental value are more closer within themselves, so it will again have high precision. Is it clear? Similarly, in this second part, this data are more closer within themselves. So it will have high precision, but they are far from this true value. So it will have low accuracy. Is it clear? Shoaib? Abdul Wahid, is it clear? Or should I repeat these words? Okay. So what you conclude about the third part, since these experimental value are far from each other, so you will say it will have low precision, but they are more closer to this particular experimental value, so it will have high accuracy. In last part, all of these experimental value are far from this true value, so it will have low accuracy, and since there is no closeness of the theta within themselves, so it will have low precision. Is it clear, Shoaib? Accuracy defines you closeness of experimental value with the true value. So in this whole part, I have assumed this center as true value, and this cross mark as experimental value related to that measurement. So these cross marks are experimental value. So if experimental value are more closer to this true value, so it will be termed as high accuracy. And since all of these experimental data are closer within themselves, so it will have high precision. Is it clear to this part? Abdul Wahid, any doubt? Okay, just write it down. Done till this part? Share. While done, this is all about accuracy and precision. Next is you have to define what do you mean by significant figure and rounding off. Suppose if there is a rod and you have to measure this rod using any ruler. So you place a ruler like this. And on the basis of the reading, you start measuring it. Let's say starting from 0. So it will be 1, 2, 3, and so on. There will be 10 divisions in this whole part. So it will be 1, 2, 3, 4, and 5. Similarly, 1, 2, 3, 4, and 5. Now, some may observe this particular measurement as along this line. Some may observe this particular reading along this line, and some may observe this reading along this line. Depending upon observer to observer, this reading would vary. Suppose for this observer, it will be 2.2 centimeter. For this observer, it will be 2.3 centimeter, and from this, it will be 2.4 centimeter. So we have first digit common in all of these three different observers, and the last digit which may vary from observer to observer. So we can conclude about this first digit termed as true value. But in the last digit, there may be some uncertainty. It will depend upon observer to observer. So this digit is called uncertain digit. So the total number of digits in any experimental value, true value, and uncertain digit combines together to give you significant figure. Significant figure is nothing but the number of digit in true value plus one uncertain digit is called significant figure. This is some basic rule to define significant figure. I'm defining you some more rule how to calculate number of significant figure in different experimental data. Is it clear what do you mean by significant figure? Sure. Is it clear? Okay. Now I'm defining you rules for counting significant figure. First is all non-zero digit, or simply we measure or we may count significant figure in decimal number. So first is all non-zero digit are significant. In any decimal number. Second, if 0 lies right to decimal but left to non-zero, then 0 is insignificant in this case. Suppose 0.04. In this part, this 0 is right of a decimal but left of any non-zero part, so it will be insignificant. Is it clear? Sure. Is it clear? Now, next rule is if 0 lies right to decimal and right to non-zero digit, then it will be significant. Like 0.40. So this 0 is right of a decimal and right to this particular non-zero digit. So these two terms will be significant. Just write it down or ask if you have any doubt in this whole part. Any doubt? have you written? Share? Done? Okay. Next is if 0 lies in between two non-zero digit, so it will be significant. Suppose 4.04. So this 0 is in between two non-zero digit, so it will have three significant figure. Next is exponential is insignificant. Next is for any non-decimal number, if 0 lies right to non-zero digit, then it will be insignificant. For non-decimal number, 0 lies right to non-zero, then it will become or it will be insignificant. Suppose if you have 6800, so this 20 is right to any non-zero digit, but there is no any decimal in this whole part. So it will have only this two significant figure. This 0 and this number would be insignificant. Is it clear? There is another rule on changing or converting unit. There will be no change in number of significant figures. Just write it down till this part. I'm defining you some more rules of counting significant figure. Wahid, have you written? Okay. Wahid, done. Try to simplify. Find number of significant figure. First, find number of significant figure in each. Just send me your answer. Share. In this first part, we have 0, right to decimal, and right to non-zero. So it will have two significant figures. In second part, we have this 0, which is right to decimal, but left to a non-zero digit. So it will be insignificant figure. So we only have one significant figure. In third part, exponential is insignificant figure. So it will be just one digit. In fourth part, since there is no any decimal, so right to any non-zero digit, so it will be insignificant. So again, we have just one significant figure in this. In fifth, if 0 lies in between two non-zero digits, so it will be significant. So in this part, we have just 2 digit, 1 digit, 1 digit, 1 digit, and 3 digit. Is it clear? Sure. Is it clear? Wahid, any doubt? Okay. The next thing is how we define significant figure on the basis of some operation. Let's say first for addition or subtraction. Suppose if you have to add 2.45 to 3.7. On adding, you will get 5. 7 plus 4 is 11. 3 plus 2 is 5 plus 1, 6. So it will be 6.15. Now, just check number of significant figure after decimal. So in this part, we have 2 significant figure after decimal. In this part, we have just 1 significant figure after decimal. In accuracy and precision, I have defined you the number of significant figure after decimal will define you its precision. So it will be more precise as compared to this. So this will be more precise. So according to the rule of significant figure, while adding or subtracting, the result of this operation should be written or reported in least precise data related to the input. So we have in this input only 1 significant figure after decimal. So we have to somehow round off this answer to 1 significant figure after decimal. So it will be 6.2. Since this is 5, which is greater than 4, so it will be on rounding off, increases this digit by 1. So from this, we will conclude on adding or subtracting, the result should be reported in least precise data related to input. Is it clear? Sure. Is it clear? Why? Any doubt in this part? Similarly, if you want to multiply or divide any 2 significant figure, suppose 2.45 multiplied by 1.2. So on multiplying, you will get 12 into 5, which is 60, 0. 12 into 4, 48 plus 6, 54. 12 into 2, 24, plus 5, 29, 1 digit and 2 digit, so it will be 3 digit, 2.940. Now just count number of significant figure as total. So in this part, we have total as 3 significant figure. In this part, we have total as 2 significant figure. The more the number of digit as total will define you its accuracy. So you'll say this is least accurate data of input. So according to the rule, while multiplication or division, the result should be reported in least accurate data related to input. While multiply or divide, the result should be reported in least accurate data related to input. So we have just 2 significant figure in least accurate data. So we have to somehow round off this digit up to 2 significant figure. So this is just 4, which is less than 5. So on rounding off, it will comes out to be 2.9 only. Is it clear till this part? Sure. Any doubt? Wahid, is it clear? You have written till this? Why? Sure, you have done till this part? So this is all about significant figure and rounding off. Now on the basis of this, we have to define theory of error. So what do you mean by error? Error is nothing but the difference in experimental value with respect to its true value is termed as error. So you will say the difference in experimental value with respect to true value is termed as error. Now we may have two different types of error. First is called systematic and second is called random. Systematic error is based on surrounding factor on which humans have no control over it. Suppose if you are using metallic ruler to find length of any object, so metal would change its dimension on the basis of temperature of surrounding. Let's say if you measure a particular object in winter, it will give you some different result, and in summer it will give you some different result. So those error which is based on surrounding factor is termed as systematic error. Next is random error, the error which arises due to human mistake. Is called random error. We may minimize this particular error by increasing number of repetition. So it can be minimized by increasing number of repetition. That's why you are being advised to take more and more number of repetition of the same measurement. So random error is inversely proportional to number of repetitions. Is it clear to this part? Sure? Is it clear? Okay, just write it down. Written to this while now on the basis of this random error, I'm defining you some calculation. Suppose while performing any experiment, let experimental data or experimental observation comes out to be x1, x2, x so on to xn. Using this, if you calculate its true value, or if you have calculated mean, so it will be x1 plus x2 plus so on to xn divided by n. So it is simply the mean of all observation. So it will be termed as true value. Now, if you subtract this true value with respect to each individual data, this term is called as deviation. Let's say delta x1 means deviation x1 with respect to true value. So it will be x1 minus x bar. Since this difference in some part give you negative value, in some part will give you positive value. So you have to take modulus, means only positive value. Similarly, delta x2 would be equals to x2 minus x bar mod and so on to delta xn, that is xn minus x bar mod. Now, if you take the mean of all these individual data, delta x bar, so it will be delta x1, delta x2, and so on to delta xn divided by n. This term is called as absolute mean error or simply error. Now, if you combine them together, so the result of this experiment will be written as true value plus minus its error part. So this is nothing but true value, and this is nothing but absolute mean error. We may neglect this bar or write it as x plus minus delta x. Now, on the basis of these two results, you can calculate first fractional or relative error denoted by delta, which is equals to error divided by its true value. Now, if you multiply this particular term by 100, it will give you percentage error. It means delta percent. So it will be equals to delta x divided by x into 100. So on the basis of experimental data, we can calculate these four different values. First, true value. Second, absolute mean error. Third, fractional error. And fourth, percentage error. Is it clear, Shwab? Till this part? Okay. Just write it down. I'm giving an example related to this. Written till this. Wahid. On the basis of this, I'm giving you one problem. If period of simple pendulum is 92 seconds, 93 seconds, 92 seconds, 95 seconds, 94 seconds. Find first true value, second absolute mean error, third fractional error, and fourth percentage error. So this is your first value, T1. This is second value, T2. This is third one. This is fourth. And this is fifth. Just put all these values and find true value. So it will be T bar, which is T1 plus T2, T3, T4, and T5. Divide by number of data, that is 5. First of all, try to solve for this part. Share. You have solved this. Just put the value of each term. So it will be 92, 93, 92, 95, 94, whole divide by number of expression or observation as 5. 2 plus 3, 5 plus 2, 7 plus 5, 12 plus 4, 999, 45 plus 1, 46. So it will be 466 divided by 5. So if you solve it, you'll get 9593.2. Now, since all of these experimental value containing just two significant figures, so your answer must be containing only two significant figures. That's why we have to round off this particular number up to two significant figures. Is it clear till this part? Share, any doubt? Good. Now we have to take deviation. Deviation means difference. Let's say delta T1, which is nothing but T1 minus T bar and mod. So 92 minus 93 is minus 1, but this is modulus, which means if I have to take only positive part, so it will be just plus 1. Similarly, delta 2 is equals to 93 minus 93 mod, so it will be 0. Delta T3, which is 92 minus 93 mod, so it will be again plus 1. Similarly, delta 4, which is 95 minus 93, so it will be 2. And delta 5, which is 94 minus 93, so it will be 1. Now take the mean of all these deviated value, so it will give you delta T bar. Just put all the values of delta in this part and take mean of it. Sure, try to solve. This is delta T1, this is delta T2, T3, T4, and T5. Just put all these values and simplify it. Why? Is it clear? Suppose if you put delta in this part, it will be 1 plus 0, 1 plus 1 whole divided by 5. It will be 1 plus 1, 2 plus 2, 4 plus 1, 5. So it will be 5 divided by 5, just 1. So your final answer for this part will be true value, that is 93, plus minus the error part, that is 1 second, as your answer. Is it clear? Abdul Wahid? Okay. Now the next part is to define fractional error and percentage error. So for this fractional error, we just use delta, which is equals to its error part divided by its true part. So on dividing, you will get 0.01. And if you multiply it by 100 to calculate percentage error, so it will be approx 1%. Is it clear? So this is your fractional error, and this is percentage error. Shab, is it clear to this part? Just write it down. You have written till this? Why? You have written? Okay. If length of a measurement L is equals to 20 plus minus 0.5 centimeter. Find first percentage error. For finding percentage error, you have to define first what would be the true value for this and what would be the error for this. So before this plus minus, this will be termed as true value, and after plus minus, this will be termed as error part. So from this you will say this is your true value and this will be your error. To find percentage error in this length, it should be equals to error divided by its true value multiplied by 100. Just put all the values and simplify it. Shwab, have you calculated this? Just put the value of error in numerator, true value in denominator, and multiply it by 100. Try to solve. We have in this part, error is 0.5, true value is 20, multiplied by 100. So 20 into 5 is 100 and 5 into 5 is 25. So it will be 2.5%. Is it clear till this? Share, any doubt? Okay. Why? Have we done till this part? Should I have done? Okay, so this is all about this random error. In next class, I will define you operation on this random error about addition, subtraction, multiplication, and exponential. And then we will start mathematical physics, which will be helpful in this whole physics course. Okay, so just revise this whole part. We'll start tomorrow. Do you have any doubt in this whole part? Wahid, any doubt? Okay then, we will meet in the next class.